Monday, I believe. At least that's what's written down on my calendar here.
I'm sorry, are we gonna get any papers back today? Okay.
Not that bottom one. Yes, you will be getting stuff back today.
What are test corrections due? If we do.
All right, so take the test on Monday. I should have it graded by Wednesday. I'm pretty fast on the tests. If somebody has not taken the test, then that really complicates the issues. But I would say probably it's going to be by September 28th.
There's 3 unit tests that are tested on.
There are 3 tests. So there's the test on Monday. There's that multiple choice test you took the first day. And then there's the final test, which it's listed as test 2 or test 3, depending upon which semester it was. Or even potentially test 4. I think I gave 4 tests on there. But if you look under the supplemental materials, not required, I think there's a category that says old tests. If you click on that, that's where you find the old tests. And typically when I create a test, what I do is, depends on how lazy I am. Potentially I can go, well, the test I gave last semester, I haven't posted it, so why don't I just reuse that? Or if I'm feeling slightly more creative, what I'll do is I go to my flash drive where I have all the information. I sort of, where all the old test ones are, I close my eyes and I sort of scan up and down like this and I click, and whatever I click on, that's gonna be my starting point. I then take that test, I highlight the whole thing in yellow to know what the original test is, then I start going through it going, I really like that kind of problem, so I'm just gonna redo one like that. That was a horrible problem. Can I possibly salvage it? If I did this, it's doable. Or sometimes I go, yeah, that's just such a horrible question to throw in there. Not even gonna remotely do anything like that. And then new problems come into the scheme. A lot from watching television. When I was still in grad school teaching an evening course at USC, at the USC, I was watching the Batman cartoon and somebody drove a car from one parking deck to another parking deck across the street, and that became a problem. That would be beyond the scope of 110. So there's some inspiration there.
And you can use calculators during it?
I hope so. Now, we have a couple of extra calculators. If you show up and your calculator's not working and you need to borrow one, that's fine, as long as not too many people need to do that. The number of calculators we have, there's an ebb and flow. Especially if the SASN is also doing a test the same day, then she'll grab calculators as well. Other questions? Yeah, you never have to ask for that. You will be on camera when you get up.
Do you have a lab today?
No, I feel like you've got a lot going on right now, so I didn't want to burden you with one more thing. I reserve the right to change my mind before we're done here. That's my feeling right now.
Keep that feeling.
There's a certain point I want to get to today, and so once I've gotten to that point, then there'll be time reserved for people who have individual questions that they don't want to ask out loud or other questions concerned.
Do we go for like a test review? Like before?
This would be the test review when I If you have questions, I'll be glad to answer them. If people don't have questions, then I'll move on.
On the test, so you know how the linear motion line where it's the graphs and you have to like do it for like for distance and position and space. You know what I'm talking about?
Right, so
Well,
you're talking about not necessarily in the lab itself, but there was the problem where an object is sliding and then you have to determine where position, displacement, velocity and acceleration were positive, negative, zero.
You know, like
Oh.
you had to draw the graph. There was like the different things.
For the position versus.
Yeah.
Okay.
Position versus time. And would that be on the test?
It is fair game.
Can we go over that?
What's the
Can we
last
go
thing?
Over some examples. Like
Okay.
that?
That's really all much better. Wow. At some point. There we go. All right, so if I have position versus time. So I'm starting at some point, we assume that this is a position of 0 and time of 0. No, it doesn't necessarily have to be, but that's the assumption I'm making. So first off, is the object moving? Yeah, because as time progresses, as I move to the right, my position is changing. If I were not moving, what would the graph look like?
Straight line.
Be careful about the term straight line. I saw with the hand gestures what people were intending there, but that is a straight line. That, better wording. So moving, not moving. So in the second one, they're not moving. I could also just, with words, I could say the position is constant. So a constant graph, horizontal. What would the displacement look like? The displacement versus time graph. So how does displacement differ from position?
Where you end up relative to the status.
All right, so that would be displacement, not necessarily. So position, and position is where you are relative to what?
Your origin.
Okay, so our origin is here. So I start out at some point away from the origin, but that's my starting point. So my displacement graph, first time, it's going to start there. You start at the starting point. It'll look identical to this, except for the fact that it's shifted. Or if it's not moving, and I had displacement first time, it would just be a horizontal line right there.
For that last one.
If I'm not moving, if I'm at some starting point and I don't move, well, that's what my displacement graph looks like. My position graph looks like that. It's a horizontal line somewhere. So this is relative to where you start. Sorry, try that again. This is relative to 0, and this is relative to where you start. So that's a very clear distinction between the two. When can they be used interchangeably?
The starting point is at 0.
Yes. Or from a philosophical point of view, also, if 0 is the starting point. Because technically I can make 0 anywhere I want it to be, so usually 0 is, you make the starting point, and then position and displacement are the same. All right, velocity. Actually, before we get to that, I want to touch on the distance aspect. That one's even worse. What are the chances those are still good? Woo! All right, so I start at some location, I end up somewhere else. So if this is, let's say that's at 5 meters, and this is at 9 meters, and this is at 0 seconds, and we'll make this 10 seconds. So over that 10 seconds, how far sorry, what's my displacement over 10 seconds?
9 meters.
That would be my position after 10 seconds. What's my displacement?
4 meters?
Yes. I started here, I went to here, my displacement is how far I've gone relative to where I started. So displacement is 4 meters. So if I did my displacement graph, that's 10 seconds, 0 seconds. 0 meters, 4 meters. No doubt, if you're drawing this down, you will draw it much better than I did. Now, if I start out at 5 meters, so again, looking at position versus time, I start out at 5 meters, I go out to 9 meters, and then I come back to 5 meters. We just established that I went 4 meters to start with. What was the distance traveled to get back?
4 meters.
So what was the total distance traveled?
8 meters.
So my distance, using the shorthand notation, just because I don't feel like writing the word distance out. Well, what's my displacement?
0.
Usually without the question mark. Now, there have been several times I've asked at various points of when is the magnitude of the displacement equal to the distance traveled. When I'm asking for the magnitude of the displacement, what's the magnitude of the displacement here?
8 meters.
That's the distance traveled. The whole thing.
0 meters.
Yeah, 0 meters. When I'm saying magnitude, what I'm asking is, first figure out what is my displacement, and then just do the absolute value. I don't care about whether it's positive or negative or direction, all I care about is just the magnitude or size at the end. So the magnitude of my displacement here is 0 meters. The magnitude of my displacement here,
4 meters.
yes. So instead of writing out magnitude of, because we're lazy, physicists are lazy.
Almost.
Magnitude of displacement, 4 meters. Magnitude of displacement here, 0 meters. I haven't gone anywhere. In the end, I haven't gone anywhere. It took me, eventually, let's put some times in here. 10 seconds, 0 seconds, 20 seconds. What was the distance traveled here?
4 meters. 4 meters.
All right, so the distance is 4 meters. So here, the magnitude of my displacement is equal to the distance traveled. There, it's not. So when is the magnitude of my displacement going to be equal to the distance? Besides, in that one case, hopefully something a little bit more general.
When the starting point is 0.
Starting point's not 0 here.
Better point.
So, I heard the voices.
When you start and end at the same place?
No, if you start and end at the same place, like right here, you start and end at the same
Right,
place,
that's
they are
right.
not the same,
Yeah.
or technically comparing those two.
When you travel in a positive or negative direction, but not both, they say instead of.
Okay, that works. When you travel in one direction. If I double back, suddenly my distance is going to start being bigger than the displacement. So there's a problem that's been asked on a number of tests where I have some object that's traveling at a constant acceleration, usually starting with either a negative velocity or positive velocity, and then moves until the velocity moving in the other direction. The distance it travels is much bigger than the magnitude of the displacement because it doubled back.
So could you say when you travel in a straight line?
You gotta be careful about that, because traveling in a straight line, because a number of people use that language, and it might be someone from 151 or 110, I can't remember which class, because that's my mind. Traveling in a straight line, I have a straight line there. I came out here and I went back, I stayed on this line here. This, to me, is traveling in a
Right.
straight line.
So it would need to be more detailed, like what you said.
Yeah, I mean, you can sum it up in traveling in one direction.
Can you just repeat what you said about when distance and displacement are the same?
All right, oh, and that brings up another point. There are a number of people in one of the master sets who talked about the distance being equal to displacement. Distance will never equal displacement. Why not?
Because when you double back, like you said.
The distance and displacement are not the same here.
Cause distance is how far you traveled and displacement is how far you've gone from the starting point.
Okay. But if you start at some place and you move, all right, so I start here, I'm gonna take 3 steps this way. What is the distance traveled? I heard 3 steps. Over here?
To the left.
Okay. Is to the left necessary for distance? Matter of fact, it should not be there for distance, it's just how far. My displacement was, yes. Displacement is a vector. A vector cannot be equal to a scalar. Now, you might be looking over here and going, well, wait a second, does that contradict what we said over here? And this is where the language comes in, and just the way it is. The magnitude of the displacement can be equal to the distance. The displacement itself, all you say is the displacement equals the distance. Displacement has a direction, distance does not. They cannot be equal to each other in that sense. Even if I would write down the displacement as plus 4 meters and 4 meters, technically they're not the same. And yes, it is nitpicking. I know what you meant. But when I was grading it, that was not my mood. I'm amazed at when I'm grading how much my mood affects the grades. Just the nature of human. All right, was there another question out there, or is? Because you had asked a question and then that sent me off on this tangent.
She asked. a
Oh,
question.
Isabella did, okay. What was your question again?
Oh, what did you say about this? When are the magnitudes the same?
All right,
I just want you to repeat that.
the magnitude of the displacement is equal to the distance if you're traveling in one direction.
Okay.
All right. Velocity. So velocity, what does the sign of velocity tell us? If velocity is negative, what does that mean?
There's one in negative direction.
Absolutely. Let's just styrofoam it this way. Assuming that this is zero, put velocity here in meters per second. What can you tell me about this line?
Constant.
Wrong word, what do you mean?
It's a constant speed.
No. What would a constant speed look like?
Horizontal.
Yes.
Sorry.
What's constant here?
Velocity.
Not the velocity.
The
Again, that'd be a
direction.
horizontal line.
The direction.
Constant negative velocity?
No, sort of where I'm
The
heading
ch-
eventually, but before we get there,
The change in velocity.
the what?
The change in velocity.
Ooh, really close.
The change in acceleration.
Changing displacement?
Hitting a lot of the key words here. Let's see if we can get in the right order.
Let me go through the calculator.
All right, so, wow, there are a couple things out there I want to address. So